Hello there and welcome back. In today's discussion, we'll be discussing more about earthquakes, seismic waves, and hazards. An earthquake is when the surface of the earth experiences an abrupt shake as a result of a sudden release of energy in the lithosphere. Earthquakes occur along a fault, which is a planar fracture along a rock that has experienced stress that has caused displacement of rocks on either side of it. You can have slight movement along a fault that is considered to be smooth without a significant earthquake. This is known as aseismic slip. In contrast, a rapid movement on a fault can cause a sudden release of energy, and this is the cause for most earthquakes. In some cases, after a sudden displacement, rocks can elastically rebound. However, rocks have a limit to the stress that they can withstand and will rupture and break if they reach their deformation limit. It is important to understand some terminology when it comes to faults. The point of origin of an earthquake is called the hypocenter, or also known as the focus. This is the first movement or break that occurs on the fault and is where the energy is first released and is located subsurface. Directly above the hypocenter on the Earth's surface is the epicenter. The epicenter is what is reported when an earthquake occurs. There are three different types of faults: strike-slip fault, normal fault, and reverse faults. A strike-slip is the result of a horizontal shear and are commonly associated with transform plate boundaries because they have a side-to-side motion. The San Andreas fault is a strike-and-slip fault. A normal fault is when displacement occurs in a vertical motion, either up or down, and commonly occur at the divergent plate boundaries because the Earth's crust is being stressed and undergoing tensile stress. The last type of fault is the reverse fault and is a result of compressional force causing one surface to be pushed over top of the other and are common for convergent boundaries with subduction zones. If we were to look at a map of major earthquakes over a period of time, we would begin to see a pattern. Not only can you see the relationship between plate boundaries and earthquakes, but there is a region that shows a large occurrence of earthquakes in this area has been named the Ring of Fire. We'll discuss this more when we talk about volcanoes. This now brings us to the next part of our discussion and focuses on how earthquakes are measured. When an earthquake occurs, it releases energy, and this energy travels in the form of a wave and is known as a seismic wave. This wave travels away from the hypocenter. Interior waves are known as body waves, which are known as primary waves or P waves. The other type of body waves are secondary waves, more commonly referred to as S waves. P waves are compressional waves and travel through matter, and as a result, matter is compressed and expanded and are the fastest body waves. P waves travel at roughly 3 miles per second and can pass through solids, liquids, and gases. When a P wave passes through matter, it is pushed and pulled apart, whereas S waves are much slower and are shear waves. S waves are the second wave to arrive at a particular location, regardless of the fact that both P and S waves start at the same time. S waves require a rigid solid to pass through in order to keep their shape. As a result, they can pass through solids but not liquids and gases because they do not have definite shapes. The following figure shows the output of a seismometer, which is the instrument that responds to ground motion and is used to measure earthquakes. As we just mentioned, the P waves are the first waves detected and can be seen here in the seismic graph. Shortly thereafter, we can see the S waves arrive. There are also surface waves, which move slower than body waves and consist of Rayleigh and Love waves. Surface waves are a result of body waves reaching the Earth's surface and transforming their energy into surface waves. Rayleigh waves are sometimes referred to as rolling waves and can be seen moving across the Earth's surface and move slower than Love waves. Love waves are surface shearing waves and are associated with horizontal movement. Earthquakes are measured in two waves by their magnitude and intensity. When referring to magnitude, this is the energy that is released, whereas the intensity is the impact of the earthquake and takes into account what people felt during the earthquake and any damage that was caused. It is important to note that intensity values are specific and assigned to a set location, can vary depending on location to location and how close it was to the event. There are two scales that are used to measure earthquakes, and those are the Richter scale, which measures the magnitude of the earthquake, and the energy released. This uses a base 10 logarithmic scale to assign a magnitude. A single magnitude is assigned to an earthquake as a whole, whereas the Mercalli scale measures the intensity and is an observation tool and uses damages and what people felt to assign a value. The observation for the Mercalli varies from little damage to total destruction. Earthquakes can be absolutely devastating and can potentially cause catastrophic damage to the area. This can include damage to buildings, roads, slope failures, highways, pipelines, bridges, and more. In the case of an earthquake that originates beneath the ocean, these can potentially result in the formation of a tsunami. Seismicity is the study of occurrences and frequency of earthquakes in a region and why they occur. Information that is considered for seismicity include history and frequency of earthquakes in the region and geological studies to examine past earthquakes. Location of known faults, tectonic plates, and information on the plate boundaries are also important factors. In addition, data on recent earthquake events and any disturbance nearby, such as mining, drilling, etc., that might be taking place around that area are also considered. Hopefully you enjoyed today's discussion on the main causes of earthquakes as well as how we monitor and measure seismic activity. Until next time, have a wonderful day. Thank you.
1, 2, 3. G.